Okay, this video is going to be talking about quadratic equations in standard form, which will look like this. This, again, looks familiar to you because that's really the form we want to put it in when we use the quadratic formula, or even when we're completing the square, we do that, or when we're factoring it, we would do that. So this is the standard form. And once again, if we're trying to graph a parabola, and again, we know it's a parabola because the highest power is x squared. If we're trying to graph a parabola, one of the first things we want to do is find the vertex, because it's very helpful to know the vertex. So that's the turnaround point, that's the line of symmetry. And if we just find the vertex and one or two more points, we can really get the shape of the parabola. Okay, so let me do a couple examples here. And so I'm going to put a couple, let's do f of x and say g of x equals 2x squared plus 8x minus 5. Okay, so if I want to graph this thing, first of all, I know that it's the basic shape of it. It's going to look like a big U sort of that goes on forever and up and out. But again, the first thing I want to do is be able to find the vertex. And so there's a little formula that it doesn't hurt for you to memorize. X equals negative b over 2a. Now you might recognize that. It looks like a part of the quadratic formula. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So notice if you look at just that first piece, that's what we have here. Okay, so this is an equation, a formula that gives you the x coordinate of the vertex of a quadratic equation that's in quadratic function that's in standard form. So again, this is the x coordinate of a quadratic equation. Sorry, x coordinate of the vertex of a quadratic function. So if I'm trying to graph this thing, the first thing I want to know is the vertex. So I just go x equals, so the negative b would be negative 4 over 2a, that'd be 2 times 1, which would be 2, and I get a negative 2 here. So that tells me that the vertex, the x coordinate of the vertex is negative 2, which means the y coordinate of the vertex is just going to be f evaluated at negative 2. Okay, and of course f evaluated at negative 2 is just negative 2 squared plus 4 times negative 2 plus 8. And that would be what? 4 plus negative 8 plus 8. And that would just be 4. So the vertex of this thing is located at negative 2 comma 4. Okay? So if we were to graph that thing, negative 2, 1, 2, 3, 4, put a little dot there. So that's the vertex. Now, of course, that's not the whole graph. We need to find more than that. So, but what it does, knowing where the vertex is, tells me where else I can look. So I've got a little chart here that has my x and y and negative 2 and 4. So then I'm just going to grab another point close to that, like negative 1, so I can really begin to see the shape. If I put a negative 1 in there, then this, of course, this is going to be f of negative 1, which is going to be negative 1 squared plus 4 times negative 1 plus 8. And that is what? 1 plus negative 4 is negative 3 plus 8 is 5. So at negative 1, I'm located at 5, aren't I? And since that's a vertex, we know immediately that that point over there also works. So at negative 3, I'm also equal to 5, right? And then I could probably just get one more, like put in 0. That should be pretty easy. When I put in 0, I get 8, don't I? Because this part's 0 and that part's 0, and left with just 8. So at 0, I'm at 1, 2, 3, 4, 5, 6, 7, 8, which means we also know that point right there because the symmetry of a parabola. And then we have a beautiful parabola. We can draw it. Okay? Now, notice I could have just done the chart and started plugging in numbers and hoped that I get lucky, but if I started at -1 and started going this way, I'd never even see the turnaround point. But by finding the vertex first, then it gives me that makes things a lot quicker and easier because I can find the shape of the parabola a lot better. So let's do the same thing here. X equals -b, which would be -8 over 2a. 2 times 2 is 4. That gives me a -2. So the vertex is going to be located at -2, comma, the function evaluated at -2, right? And the function evaluated at -2 is 2 times -2 squared plus 8 times -2 minus 5. So that would be what? 8 minus 16 minus 5. And that would be -8 minus 5 is -13. So the vertex of this thing is going to be -2, comma, -13. So if I wanted to graph it, just go over here, go out to -2, go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And if I plug in, so there's my beginning, my t-chart, x, y, I put in -2, get out -13, put in -1. If I throw a -1 in there, I get, you can do that on the side, but what you'll get is -12. And since that works, we know this one also works. If I plug in 0, we will get -5. 1, 2, 3, 4, 5. I'm sorry. No, you wouldn't get -12. I did that wrong in my head. Sorry. You'll get -11, not -12. Get -11. So that means this point would be there and that point would be there. Since that's there, then we know this is also there. And then once again, we can draw our cool parabola. Okay, so again, the key is finding that vertex first, zeroing in on the symmetry of the parabola, and then find a couple more points so we can graph the rest of the parabola. All right, so that's the 3 different forms of the parabola we talked about in the first video. Vertex form, second video we talked about factored form, and then just got done talking about standard form. So next video, we're going to talk about a couple other particulars that are important to notice, and we'll talk about how to switch back and forth between the different forms. All right.